Math Humans. We're going to do 3.6 today. 3.6 is a summary of curve sketching. So basically, we're going to do one big example that's asking us to analyze and sketch a graph without a grapher. So as we talk about analyze, that means find the x-intercept, asymptotes, intervals of increasing and decreasing, concavity, and inflection points, which means we're going to be using the first and the second derivative test. So the first thing that I would answer would be the x-intercept, and remember that that comes from the numerator. Okay, so I would bring in my trusty calculator, and I would do the quadratic formula. I'm going to clear, and I would do the quadratic formula, option number 6 on my calculator, enter, and I would enter 1, -2, and 4. And you notice that I get imaginary numbers, which means that I have no x-intercept. So for the x-intercept, I'm going to write none. Alrighty. I do know that I have a vertical asymptote at x is equal to 2. And for my slant asymptote, the degree is higher in the numerator. When I divide x squared by x minus 2, I'm going to get y is equal to x as my slant asymptote. So that has answered a few of the questions. All right, so now let's talk about my derivatives. So if I do f prime of x, okay, this is not reducible to make it simpler, so I'm going to have to do the quotient rule. So it's going to be low d high, so the derivative of the high is 2x minus 2 minus the high, x squared minus 2x plus 4, times the derivative of the low over low squared, okay? And unfortunately, this does not simplify. I can't factor out an x minus 2, so I'm going to distribute everything, and I'm going to get 2x squared minus 2x minus 4x plus 4 minus x squared plus 2x minus 4, and all of that is divided by the x minus 2 squared. So now if I try to clean up the numerator, 2x squared and x squared is going to give me an x squared. The 2x is cancel, and then I'm going to get the 4's cancel, so x squared minus 4x over x minus 2 quantity squared. So that is my derivative. Okay, remember that we are identifying our work, so that means that we're showing what our work is, and I'm going to set that equal to 0. When I set this equal to 0, I'm going to get x is equal to 0 from cross multiplying, and so in the numerator I'm going to factor, and I get x minus 4 is 0. This confirms that extra 0, and then I'm going to get x is equal to 4. So those are my two critical points. Okay. Now I'm going to do my sign chart. So here's my 0 and a 4, and I'm going to choose a -10, 1, and 10. So I'm going to evaluate the derivative at a -10, and I'm going to get a negative and a negative. Oops, I'm sorry. I have to do it in both places, and I get a positive divided by a positive is positive. And I'm substituting this back into my derivative, and so that means in this interval the function is increasing. Okay. Oh, point to note as I look at my work, I have to put a vertical asymptote, and so I'm going to add a 1 and a 3 as things to check, because a vertical asymptote is going to change the graph, so I want to make sure that I include that as one of my critical values. So now I'm going to do f prime of 1, and when I do that, I get a negative, so I'm going to put that goes down right there. I'm going to do f prime of 3, and I'm going to get another negative, okay? And then I'm going to do f prime of 10, and I'm going to get a positive, alrighty? Okay? I do have an asymptote. It's a vertical asymptote, so remember that's going to push my curve, okay? And I have a slant asymptote. That one is just harder to put on my graph. Okay, so now I'm going to answer questions. Typically I would do it on the right, but I'm running out of room, so I'm going to have to go to a second page. So I'll just list here. F of x is increasing from a -infinity to 0. and then it is increasing from 4 to positive infinity. F of x is decreasing from 0 to 2, and then again from 2 to 4. I have to have a break in here because of the vertical asymptote. So if there hadn't been an asymptote, I could have just written one thing. I have a maximum at x is equal to 0, and so that would be 0 f of 0. And then I have a minimum at x is equal to 4, and that would be 4 f of 4. Okay? All right, and so that's everything that I would have used for my first derivative. I'm going to go ahead and rewrite my first derivative so we can see it again on the second page. And I had x squared minus 4x over x minus 2 squared. And now I'm going to take the second derivative, and again I have to do the quotient rule. So it's low times the derivative of the high minus high times the derivative of the low, which is the chain rule to the first, times the derivative of the inside, over x minus 2 squared squared, okay? And so now what I'm going to do is I'm going to factor before I try to expand all of this stuff. So I'm going to take out an x minus 2, and when I do that, I'm going to get 1x minus 2 times 2x minus 4, and then here's the negative, okay? That guy's going to go away, so here's the 2, and then I have x squared minus 4x. I always recommend that you factor before you distribute if you can, and this is to the 4th. Now I know that that goes away, and I get x minus 2 to the 3rd, okay? Alrighty, and then if I continue to simplify, this is going to be 2x squared minus 4x plus 8 minus 2x squared plus 8x, and all over x minus 2 to the 3rd. So then if we clean all this up, I have an 8 and an 8, so those guys cancel. The x squareds cancel, and so I get that my second derivative is going to be 8 over x minus 2 to the 3rd. Alrighty, so that's actually kind of a nice second derivative, and I'm going to set it equal to 0. So what we'll notice in this is I may not have any critical points because I have nothing in the numerator. So I'm going to evaluate my second derivative at the vertical asymptote of x is equal to 2. So I'm going to evaluate 0 and 10. So f double prime of 0 is going to be negative, which means it's concave down. And f double prime of 10 is positive. And again, I'm evaluating this in this function. And f of 10 is positive, which means it is concave up. So if I answer the questions that would come from the second derivative, I have f of x is concave down from a negative infinity to 2, and f of x is concave up, forgot the n, from 2 to positive infinity. All right, and because the concavity changes at the asymptote, there are no inflection points. There's not an actual point where the concavity is changing. It's changing at the asymptote. So if I took all of the information that I had gathered, so I know that at 2 I have a vertical asymptote, and my slant asymptote was going to be y is equal to x, and then I could manage all of my different information, and I would come up with a sketch of my graph, okay? And that would be it. So there's an analysis of our function. That's it for today. I will see you soon.